Morning students. Today we will start the new topic, new chapter, chapter 5, continuity and differentiability. Before starting continuity, we have two sections, first continuity and second differentiability. Obviously first we'll see the continuity. For looking continuity, we have a good knowledge, we must have a good knowledge of limit. Limit, the portion already you have studied in class 11th. So today we'll recall all the knowledge of the section limit, which already you are aware about in class 11th you studied. So first of all we see that how limit works, what kind of limits there are, how we get value of limit. Look at, suppose we have a term limit extends to a f of x. So one should clearly know that when we apply limit extends to a for any function or on any function, that it gives the answer f of a, meaning x tends to a, it gets f of a. We should aware about that. What is meaning of x tends to a? Meaning x approaches to a. Try to understand. X goes near and near to a. It never meaning that x is equal to a. X is equal to a. So finally I would speak one thing, that it is completely meaning that x is approaching to a. And the meaning of that x is approaching to a, what its meaning? Actually, if I put one example to you, that if you have x tends to x plus 3, so what is its answer? So one should simply apply the limit on that, or he or she will say that it is x tends to 2, 2 plus 3, 5. I know it is 5. But what is the meaning of tends to 2? So meaning x is going to 2. And again the meaning is x is going to 2 of which direction? So let me clear that. Suppose it is 2, obviously it is 3, it is 1 and it is 0 and something like that. So if I say that x tends to 2, x is going to 2 from 2 direction. Either x can come to the 2 from the right direction, or x can come to 2 from the left direction. So with the small this kind of value box, I can explain that. Suppose it is x and it is a function of x. When x is going to 2 from the left direction, what is its meaning? Its meaning that it is here. I would say x, it is, the value of x is 1.99, suppose 1.99. So answer is, when you will put 1.99, you will get 1.99 plus 3 is a 4.99. When x is going very near to 2, suppose here it's a 1.999. So your answer will be 4.999. So one should aware about that. When x is going near and near in 2, suppose 4 times 9, so answer is 4 times 9. So when this procedure will be till infinity, it is 1.99999 infinite time. So your answer 4.999 infinite time. One should know that 4.999 till infinite time gives a 5. Even it is not actually 5, but we consider that it is 5 because it is so close to the 5. So okay, it is 5 again. So this time when x is approaching to 2 from the left direction, we get a 5. Similarly, when x approaches from the right direction, from here, so okay, suppose this point is x and it is f of x. Suppose x is very close to 2, which is 2.01, then answer is definitely 5.01. When again x is going very near to 2, again close to 2, it is attaining the value 2.001. So your answer will be 5.001. So this term, if the procedure will continue to infinite time and it is very near to 2, I'll write 2.0 there, and then 1, I'll get 5.0 between them, and then 1. Finally I would say that 5 point between these two, we have infinite 0, so no sense of 1, will again have a 5. So in both cases, it is not exactly 5, but it is very close to 5. So we consider that the limit of the value of the limit is 5. So student, these were the two conditions. Now if we put directly x tends to 2 5, it is called a right answer. But we should not forget the real meaning of limit. Now this is a limit, x tends to a, and I want to go with that how we get f of a. So we have to go for two limits. First I'll go with the right hand limit. So what's the meaning of right hand limit? Now recently you saw that when it was a 2 and x was coming from the right direction, when x comes to the 2 from the right direction, it is called a right hand limit. When x comes to 2 from the left direction, it is called a left hand limit. So in very first case, it is a, x is approaching to a from the right direction, and with the picture I want to clear to you that how we deal this. Suppose it is a 0 somewhere, and suppose it is a, and suppose x tends to a from the right direction, x is coming to a from the right direction, and this right hand limit I will write x tends to a plus f of x. Try to understand it. All conditions actually I have explained when you were in class 11th. Still again I am telling you because it is very, very important. Right hand limit meaning x is approaching to a from the right direction, and it is shown by x tends to a from the right direction. So plus meaning x is coming to a from the right direction. Okay, suppose that x is here and it is coming from the from the right direction to a. It maintains the gap h, which is very small. It maintains the gap h, which is very small. Definitely x comes to a, h destroy, h gets 0. So okay, that all I'll tell you later. First look at the figure, and now I'm writing to see the picture. Here look at properly, x is equal to a plus h. Try to understand. When you will think that why I have used equal to and what is this h, so don't see here but look at the picture. You will get everything. X meaning from this, look at my hand, 0 to x, 0 to x, this is x, equal to a plus h. This is a and this is h. So a plus h is equal to x. This whole x, from 0 you have to count all the distances. 0 to a, it is a. This is h. So I would say this to this was a x. X is equal to a plus h. So this is written here. You should not surprise. The picture shows and display everything. Everything. Okay, from this particular, don't see now the picture. I have written like that. If you want to clarify yourself, you can see the picture. Now, as I'm writing very important thing, when h will go to the 0, now the meaning is this, x is approaching to 0, meaning h is getting smaller and smaller. So look at the thing, a is fixed and x is moving. X is moving towards the a because meaning of x tends to a, meaning x is coming to a. From which direction? Right hand limit, from the right direction. So x is coming to a from the right direction, x is coming to a from the right direction, x is moving slowly and slowly to the a. In whole the procedure, h will decreased. So h is going to 0, meaning h is decreased. When h is decreased, what is happening? Actually x is coming to a from the right direction. Look at properly. When x is coming to a from the right direction, then only h is getting 0. H is getting 0. Now x is coming slowly and slowly to the a, h is getting reduced. And that's why I am writing here, when h is getting reduced, h is getting 0, then x is coming to a. And this particular replacement, I want to go with this term, student, x tends to a plus. Instead of that, I want to write h tends to 0. And in case of f of x, we have a x is equal to a plus h. I want to write same here. Ultimately, we consider that h is getting 0, meaning h gets 0. Even we know that h never gets 0, but ultimately we assume that h is getting 0. When h is getting 0, f of what come? A plus 0, meaning lastly you will have f of a. So ultimately your answer is f of a. While taking RHL, we did the procedure, but still answer is f of a. F of a. And similar work from the left hand side, left hand limit. For left hand limit, what would happen here? Look at, I tell you. when I remove all, I rub all, and now I'm taking, suppose it is x, and x is coming from the left direction, with maintaining the gap h, and now it is the LHL, left hand limit. Look it properly, left hand limit, denote with x tends to a minus f of x. This time x is going to a from the left direction. Okay, now similar procedure I will do. What answer I'll get from here? You can see that x is equal to a minus h. Now you should not surprise. If you want to clarify yourself, you can see the figure. X, this distance. So it is a, because you have to count all the distances from 0. It is x, it is a. So a is this distance minus h, this distance. What comes? X. So a minus h equal to x equal to a minus h. Both are same. Now this particular will tell you that x is equal to a minus h. When h will go to 0, what will happen now? It's very easy. When h is getting 0, meaning x going to a from the left direction. As x will approach to a from the left direction, slowly coming near to the a, h will definitely get 0. When h is getting 0, x will go to a from the left direction. And when you have written, similar I have written this, so the same mentality both keeps. Okay, now I'll change my limit x tends to a minus, as h tends to 0, instead of x I'm writing a minus h, and put x equal to 0, I'll get a minus 0, ultimately f of a. So in both cases, guys, whether you have used LHL or LHL or RHL, you got f of a. So meaning is, directly if you put value of x is equal to a, you will get f of a. Now you are thinking, so why, if directly we can put, why we are using this? But this is very important. One should know when LHL and RHL are equal, that limit exists. Limit is exist. Or unfortunately, if LHL and RHL, in some cases, if they are not equal, I would say that limit does not exist. Question might have come that show the existence of limit. That time you have to prove both limits are equal. If both limits are not equal, limit will not exist. So this was a procedure. Now student, it should be in your practice how to find right hand limit and how to find left hand limit. Okay, without rubbing all this, I want to tell you one question. Even from the book, I am not telling you even a single question, but the concept of limit you should first clear from your side, that okay, we know it. Okay, I'm writing one question, very simple question. I'm writing limit x tends to 2 plus x plus 7. What is its answer? Even it is a plus sign. So it seems like that. So you have to do all the work. But I would say something. Okay, first I want to do all the procedure. Here x is equal to a plus h. I'll write here x is equal to 2 plus h. This time I'll say let, because I don't have a figure. This time I had a figure, h was clear there, here I wrote. But this time I don't have a figure. So you just have to catch from this condition that x tends to 2 plus is being here. So we consider x is equal to 2 plus h. We are assumed here only. And now tell me one thing, as h will go to 0, when h is getting 0 and 0, x will approach to 2. Such h is getting 0, x approach to a. Such h is getting 0, x will approach to 2. From which direction? Right direction, because it is right hand limit. When I have changed all this, I'll convert to that x tends to 2 plus as h tends to 0, and instead of that x, I will write 2 plus h plus 7. That time we have a x, and I wrote instead of x is equal to a plus h, then I use the limit. Similarly, we have a x is equal to 2 plus h. In function, I turn, and whole function now turn in h. Now you can put h tends to 0 here. So 2 plus 7 is 9 itself, plus 0, we can answer 9. So directly, you know that x tends to 2 plus is deal with like that. Now I will give you some suggestion. You should, guys, make the habit. Do not do this work. Do not do this work. And directly skip these two terms and jump here. Come here. Now student, make a habit to write what? Look at here. Don't assume x is equal to 2 plus h. But write always convert that, h tends to 0. Instead of x, write 2 plus h. Shortcut. Instead of x, write 2 plus h and plus 7. So your answer is h tends to 0 plus 7, answer is 9. So you should make habit to do this. Okay, let me explain one more thing. Suppose you have limit x tends to pi by 2, suppose sin x plus cos x. This is a question with you. Sin x only, plus, like that. If you have this kind of condition, how you deal? You just don't worry about, don't assume between them as I did in previous one. Do directly and shortcut. Use shortcut. How? Write in h. Because we know that it already or ultimately convert in h, so write is h tends to 0, and instead of your x, write pi by 2 plus h, and go with this. Sin 90 plus theta is cos theta, and limit h tends to 0, put h is equal to 0, cos 0 is 1. Now this is an answer. So hope student you are getting here that how we can find the right hand limit. Similarly, if you have a left hand limit, we'll do the same. I'll write h tends to 0 always. Instead of x only, I will write pi by 2 minus h. It means that I am not using these two terms. I am directly writing that to here. It automatically turns as h, and instead of x, we will write a plus h. So similarly, I'll do the work, and further you know it very well. So these were the concept of limit, students. Left hand limit and right hand limit, how we can use directly them I have explained, and tomorrow I will start the major thing of each chapter. Thank you.